Hello everyone, I hope you guys are doing good. Today, I, Shivam, will be talking about my term project, Deep Q Learning for Financial Trading. Here's a look of my dataset. The dataset has few of the major stocks such as Apple, Microsoft, Amazon, SPY. Here's a simple EDA. Now talking about the dataset, the data here is of the following stocks mentioned on the right-hand side of the screen, and the data is from 2010 to 2020. Now the main problem statement. The financial industry is characterized by dynamic and complex market conditions, necessitating intelligent decision making to optimize trading strategies and maximize profits. Traditional approaches have often fallen short in adapting to rapidly changing landscape, prompting the need for innovative solutions. So, the Deep Q Learning for Financial Trading project addresses this challenge by leveraging reinforcement learning, specifically Q learning, to train an agent capable of making informed trading decisions. The key problems to be addressed here include optimal parameter generation, maximize profitability, data preprocessing challenges, generalization to deep reinforcement learning, and a broader context of reinforcement learning in finance. So the following parameters have been generated for the training of our base learner. The parameters here are log returns, simple moving average, momentum, volatility, direction. Talking about Q learning, here we have a reward function, a action policy, and for the base learner, I'm using neural networks. In these neural networks, features are the parameters that describe the state of environment and labels are the values attached to each allowed action. Talking about the exploration versus exploitation trade-off, the exploration refers to the action taken by agent that are random in nature. The purpose is to explore random actions and their associated values beyond what the current optimal policy would dictate, and this optimal policy is known as exploitation. We also have a replay that does a continuous updation of optimal policy given the new experiences. The epsilon defines the ratio with which the algorithm relies on exploration as compared to exploitation, and the epsilon decay defines the rate at which epsilon is reduced. Here's a look of the parameter initialization. Here's a look of the deep neural network. My neural network has two hidden layers of 48 hidden neurons and an output layer of two neurons. I've used MSE for loss computation and an RMS prop optimizer with a learning rate of 0.0001. Here we can see the financial deep Q learning agent and its training. The training has been done for 150 episodes, and we can see the performance has increased from 0.83 to 1.895. The final epsilon here is zero point 0.1. That means a 10% exploration rate. The performance here determines that we can successfully trade with a return of 189.5%. This can also be seen in the following graph. For the training, we have obtained results in some of the episodes that gives us more than a tenfold return. We can also see that our validation comes to a stagnant after 130 episodes and can continuously provide us with a return of approximately 200%. And thank you for being such a great audience. I hope I was able to convey what I learned.